I will dive into Earth observation linked with citizen science, and in particular, obviously because I'm working at Synergize, particular with the Sentinel Hub services. So just to give you a little bit of background, what is happening in this field, let's say. So recently, I would say that we've entered the era of Earth observation data. So we're talking about big data everywhere, and it's really a lot of it. But what that actually boils down to is really a lot of technical issues and problems that we're all having. So instead of calling it a revolution in EO, I rather call it chaos in EO. Well, maybe not chaos for Earth observation experts, but definitely it means a lot of tedious and costly work for everybody to make any kind of sense out of this huge amount of data. Definitely for non-EO Earth experts, this is chaos. So where to get the data, how to get it, in what kind of format it is, how can I visualize it, how can I do anything out of it? That's really a really big chaos. So at Sentinel Hub, at Synergize actually, we have a mantra, and that mantra is that we stop treating satellite data as a set of files that we have to process. They are much rather than set of tiles, they're just a set of pixels. And this set of pixels carry a very high potential value. So this service that is outlined here, and don't worry, I won't talk about the service because it will take me a better part of the day, but the service takes away the tedious and boring tasks. So it allows users to focus on getting value out of satellite data and not spend time on the really technical, gory details like getting the data, storing it, decoding it into a format that is useful, stitching it together, reprojecting, parsing metadata, doing, I don't know, things like backscatter calibration, auto rectification if you're doing with if you're going into satellite into SAR data, and so on and so forth. So if you're really interested, have a look at the sentinelhub.com site. And now I will move on into the Earth observation in LandSense. So LandSense, we've heard a lot about LandSense already by Ian. It deals with land use and land cover monitoring, right? And the data that we have nowadays, a lot, again, comes from Earth observation satellites. I will just go briefly through what kind of services and what kind of things we had to do at LandSense, or we did in LandSense, with Earth observation data. So just to give you a quick overview of what we've done. So we've used Sentinel-2 imagery for the agricultural monitoring. We've used it in, and this is what Ian already showed, in the change detection in urban landscapes. We've used, again, Sentinel-2 and Sentinel-1 data for forest change detection, particularly in Indonesia and Flores Island. And last but not least, we've joined OSM data, OpenStreetMap data, which is one of the biggest, I would say, citizen participatory data out there, with Sentinel-2 data to create this land use, land cover map tool. Now, this is about Earth observation, and you might have remembered that my topic is actually about Sentinel Hub in LandSense. So how did we use Sentinel Hub services? Well, actually, these services allow us to integrate various applications with satellite data. So for instance, in the City Oasis application, in the first picture, I'm not sure whether you'll be able to discern it, but there is a thermal, Landsat 8 thermal data displayed on top of the data that has been collected by the users. In crop support application, which is focused to the agricultural use case, the maps shown are also coming from Sentinel Hub services. So things like NDVI, vegetation index, moisture index, and so on and so forth. As I mentioned, the Natura Alert application, the data showing the detected changes in the forest also come from Sentinel-2 data, at least at some point in time. And Inyan also mentioned the picture pile. So this example is a really, I would say, very simple example how linking two services, so a picture pile application on one side with Sentinel Hub service on the other one, it allowed us to create a large data set of tiles where users actually let us know whether there are any clouds in the image or not. Unfortunately, with Earth observation, I tend to call our Earth a modest lady. She likes to cover herself with clouds, and unfortunately, we would like to see what's beneath. So clouds are a problem, and application like this allows us to build a model that tells us where clouds are and then how we can remove them even. I will here mention another thing. So this is one of the panelists from the previous hackathon, the previous LandSense challenge, and the application actually kicked off as a blue dot water observatory. So Sentinel-2 data is here used to delineate the water bodies around the world. And sometimes you can see that this delineation, which is in the yellow line, represented in the yellow line, is good, like here. And sometimes it's really, really bad. So we were wondering how we can address this issue. So the Blue Dot Observatory uses algorithms to find out water bodies. And obviously those algorithms are sometimes performing well, sometimes not so well. So we asked, okay, but how can we improve? And obviously we can only improve if we have data collected where the water bodies are and where they are not. So we came up with a, okay, there's a mismatch here. So this one should be shown first. And unfortunately, it is not shown clearly, but it is application that allows us to actually, on a pixel basis, tell what is where. So in the picture below, you would be able to see, if I didn't screw this up, you would be able to see where the water is. So users were asked to paint the water bodies, and using that information, when we stored it and compiled it, we managed to build a better model to delineate and find water bodies. And now there are some more examples of this classification app. This one here, for example, is trying to actually confirm whether the model is correct. So users were asked to fix the model where it is wrong, and that the resulting data set has been open sourced by the Radiant Earth Foundation as the benchmark training data land cover net for Africa. So this is one, let's say, potential collaboration of Sentinel Hub services, Earth observation, and citizen science. So moving on, the topic of this title is actually Earth observation for everyone. And if you remember at the beginning, I said that actually Earth observation or revolution in Earth observation is actually a chaos. Luckily, I don't really believe that, or at least we tend to change this fact. And one thing that we are at Synergize working on quite extensively is the Sentinel Hub's EO browser, which is a web application specifically tailored, let's say, to, well, basically everyone. So how can we get Earth observation data in your hands? Let's have a look. So EO browser, which is accessible on this URL link below, is a web application that facilitates access to the data. So you go here, you pick a place wherever. Rome is our typical use case and example, but you can go to any place in the world. You select your data source, which can be, as you can see, Sentinels, or it can be Landsat and even other data sources. You search for a particular time range, you select maximal cloud coverage and stuff like that, and then you are able to find the data that you're interested in. You scroll down and maybe pick the one that you're most interested based on, I don't know, cloud cover or something like that. And immediately you're able to visualize it in your browser, move around, zoom, pan, and so on. And look at either Sentinel-2 level 1C data or even the one that is atmospherically corrected, right, in your browser. So you can do something very fancy here. You can select other visualizations. You can write your own visualizations and so on. Zoom in, zoom out, as I said. So in fact, to produce an image like here, that if you had the time to do it yourself and the resources, it would take you a better part of 2 days, I would say. While with your browser, you manage to do this in seconds. You can build your own time lapses, which is a great tool to visualize the changes in time, just to visually appraise what has happened in a particular area. Limiting out the cloudy observations, obviously, because we are never interested in those. And even more, you can do some statistical analysis. So you delineate the field and you get a NDVI chart over time and see what the values are. So if you're interested more in agricultural, that's already agriculture, that's already all there. And even more, so recently we've developed something that is called data fusion. So you can combine data from several sources and then create visualizations like this one, which is a cloud pressure from Sentinel-5 P images on top of the Sentinel-3 LULC true color scenes, and visualize then the evolution of the hurricane. I don't know which one, unfortunately. How about collaboration and sharing, which is, in my opinion, quite a big part of citizen science as well. So there are two things I would like to expose here or particularly talk about. So one is the custom script. So there is a lot of knowledge hidden in the Earth observation. So how do you combine various bands from various satellites into something that tells you a little bit more about what you're looking for? And that's why we came up with the idea of publicly hosting these custom scripts, which tell you how to combine the bands into something like burnt area visualization. So if you're interested in what kind of area was burned by fires, this is one script that would help you to do that. And you can immediately see this script results in your browser. Or maybe this one, which is the forest cut detection script, which actually combines multi-temporal data to get to the results. And the other one is something similar, but it's called pin library. So if you have something, some places in the world and in time, because the Earth observation data is spatial and temporal, you can, and you find something interesting, you can save those locations, you can save the times and everything, and share them with everybody. So people can go and open up your collection of what you deemed nice or what tells a story, and you can share then this story with everybody by sharing your pin library. So hopefully I didn't take too much time. I'm still 1 minute short of the 15 minutes. Sorry, Ian. For more info, just have a look here and don't hesitate to reach out to me. Thank you very much.